fi pressure who no book. If you not have no education, people treat you like a book.
Hello everyone. Welcome back to another tutorial in this COVID-19 pandemic season. These series of tutorials are dedicated to the parents. Thank you very much for all the hard work that you're doing at home. Together, we're a team. Today I'm going to continue in the series of lessons on angles in a triangle. In my previous lesson, I looked at angles in a scalene triangle. Today, we're going to be looking at angles in an isosceles triangle and an equilateral triangle. So an isosceles and an equilateral. So an isosceles triangle and an equilateral triangle. Let's begin by identifying what's an isosceles triangle and what's an equilateral triangle. Here we have a triangle. At the moment, we do not know what type of triangle it is. We're assuming that's a scalene triangle. However, if I put two lines like that on it, it is telling me that it's an isosceles triangle. An isosceles triangle is one in which two sides are equal. You might sometimes see the sides that are equal using double lines instead of single lines. It's the same thing. It means these two sides are equal. Bear in mind that it can be turned anyway. So it means these two sides are equal. It means these two sides are equal. In an isosceles triangle, we have two equal sides, but we also have two equal angles. How do we identify which two angles are equal? Now, the two angles that are equal are always opposite the two equal sides. So here, the angle opposite over there, and there, the angle opposite over here. So these two angles are equal. So let's say we call that angle B. Then this will also be angle B. If we look at this one, we know that these two sides are equal. But which two angles are equal? The one opposite the side that is equal. So opposite over there, that angle. This one opposite over here, that angle. So this angle and this angle, they are the same. So if I should call that X, then this would be X as well. If we look at this one, we know that these two sides are equal. Which two angles are equal? The one opposite over here and the one opposite over there. These two angles are equal. So again, if I call another letter, let's call that T. Let's call that T. In other words, whatever this is, that's going to be the same thing. If I look at this one, these two sides are equal. This angle and that angle, these are going to be the same. So let's say this was 50. If that was 50, this would have been 50 as well. These are what we call the base angles. So in an isosceles triangle, the base angles are equal. So an isosceles triangle has two sides that are equal and two angles that are equal. Two sides that are equal, two angles that are equal. Two sides that are equal, two angles that are equal. Two sides that are equal, two angles that are equal. So an isosceles triangle has two sides that are equal and two angles that are equal. Now let's talk about an equilateral triangle. An equilateral triangle is one in which all three sides and all three angles are equal. We identify an equilateral triangle by noticing the three lines. So that's an equilateral triangle. All three sides are equal. Also, all three angles are equal. In this case, we know what the angle is going to be. Because if angles in a triangle adds up to 180 degrees, if I have 180 divided by 3, I'm going to get 60 degrees. So in an isosceles triangle, all the angles, so in an equilateral triangle, all the angles are always going to be 60 each. So there's not much calculation that is needed in an equilateral triangle. In an equilateral triangle, all the sides are equal, all the angles are equal. The angles are always going to be 60. The sides you will be given. So if this is 10, this is going to be 10, that's going to be 10. Whatever, you will be told what the sides are, but the angles will always be 60. Let's look at some calculation with isosceles triangle. Since there's not much calculation that is needed with an equilateral triangle, we're going to concentrate on an isosceles triangle. Here I'm given a triangle. I'm going to put those two lines there indicating that these two sides are equal. Now I'm going to give you this to be 64 degrees. I'm going to ask you to find this one, and I'm going to call that x. How are we going to find x? We know that it is an isosceles triangle, so we know that two angles are equal. So if we look, we know that angle is 64, and this angle across here, these two are going to be equal. So straight away, we know that this one will give us 64 degrees as well. But we were not asked to find this one. We were asked to find this one. Angles in a triangle adds up to give 180 degrees. So we first add 64 plus 64. That's going to give us 128. Now this and this makes 128. So I'm now going to say 180, take away 128, and my answer is going to be equal to 52. So x is going to be 52 degrees. We could also decide to set this out another way. We could say 64 plus 64 plus x, which is 64, 64, and x, and we know all three should give 180 degrees. We could show our work in that way. If we add 64 and 64, we're going to get 128. So we could say 128 plus x is equal to 180. Now, how are we going to find this x? We're going to take away 128 from 180. So we say x equals 180 take away 128. And we're going to be left with our answer there as 52. So any one of those methods we use to work it, we'll get the answer for that one. Let's look at another question. This time, these two sides are equal. This is the angle 76, and I'm asking you to find angle, let's call that angle P. But I know that that is 76 degrees. First thing I know is that's an isosceles triangle. So two angles are going to be the same. Let's identify the two that are going to be the same. That side, the side opposite it, so that one and that one, the side opposite it. So that is P, then that's going to be P as well. So these two are the same. Now, how am I going to find P? I'm first going to take this away from 180, and the answer that I get, I will half it because it's going to be the same for these two. So I'm having 180 take away 76, and my answer is going to be left with 104. That 104, I'm now going to say 104 divided by 2. And again, this is going to give me 52 for my answer. So P is going to be equal to 52. So my answer is 52. But I could decide to show my work in another way. I could decide to say 76 plus P equals 180. 76 plus 2 P's equals 180 degrees. How am I going to find? So I know these 2 P's, if I take that away from 180, these 2 P's are going to be left. So 2 P's would be 180 take away 76. So my two p's together would be 104. So if I want to find the value of one of the p's, it is now going to be 104 divided by 2. So now I know then, again, my p is going to be equal to 52 degrees. We're now going to be looking at another triangle. This time I'm asking you to find the value of this angle, this x. What do we notice? We have two triangles. This triangle is an isosceles triangle, indicated by these two sides being the same. But this triangle is also an isosceles triangle, indicated by these two sides being the same. The reason why we have that one with a double line and that one with a single line is just to distinguish between the two triangles. We're asked to find the value of this x. Now, these two base angles are the same, and we know that angles in a triangle adds up to 180 degrees. So if I find these two, add them together, and take it away from 180, I will get this one. But how am I going to do that? Here I have another isosceles triangle. I'm told that that is 70, so this must be 70 as well. If I add these two, 70 plus 70, I get 140. So 180 take away 140, and that's going to leave us with 40 degrees. So I know that this is 40 degrees. If that is 40 degrees, then here is going to be 40 degrees as well, because vertically opposite angles are equal. And remember that this is an isosceles triangle. So if that is 40, that's going to be 40 as well. Now we have enough information, we can work out x. 40 plus 40 is 80. So 180 take away 80 is going to leave us with 100. So x is equal to 100. Let's look at how we could get a question on an equilateral triangle. In an equilateral triangle, remember, we know by the indication of all three sides are the same. And we also know, without having to be told, that in every equilateral triangle, each angle is 60. So if I ask you to find that, and let's call that angle y, we know that angles on a straight line adds up to 180 degrees, because here would be the turning point. So 180 take away 60, and that would be leaving us with 120. So just a quick roundup, we looked at isosceles triangle, and we know that an isosceles triangle has two sides equal, two angles equal. The equal sides are usually indicated by a line. It's usually 1 or 2, so it can be indicated by a single line like that or by a double line. The angles that are equal are the angles opposite the equal side. So that is one of the equal sign, the angle opposite. That is one of the equal sign, the angle opposite. So these two are the same. They're called the base angles. Same thing here, that's opposite there, so that angle, that's opposite there, that's at that angle, these two are the same. In an equilateral triangle, we have all sides, all angles are equal, and each angle is 60. The side is dependent on what is given to you in an exam. Hopefully this helps.
If you not have no education, people treat you like